Okay, so I should have started recording and I did not, and I thought, it's not going to be anything special, but turns out that it was actually a pretty good problem to troubleshoot. Yeah, it would have made a good video, but I'm going to catch you up and I'm going to pretend that we didn't do anything, and I'll walk you through what I found because it could be useful for anyone else. Here we have a Sony STR K7, well, in my case, K840P is the model I've got. Looks the same. Yeah, surround sound receiver. So, when you turn it on, you get a little indication on the screen. It comes up. It does its little self-check timeout thing and goes to switch on the relays. All of these devices have a relay in the speaker output so that it can maintain protection to the speakers if there's a problem with the output. You don't want to send full rail voltage through to your speakers and destroy them. And in this case, this was happening. It was coming up with a message protection, and yeah, it was not enabling the output because there was a fault detected somewhere. Now, of course, I went through looking for reset procedures, as you should do. A lot of these intelligent systems may throw a fault because of a short on the speaker lines. Once you remove the speakers, that fault is cleared, but it doesn't always clear the error status and may never work again, as in a previous video I've done. So you should always try and reset the device. I tried the resets that I could find. Nothing took it out of protection mode, so there's definitely a hard fault inside causing it. Taking the lid off, we can see it's pretty much an amplifier made like most of the amplifier receiver units out there. We have our row of output transistors on the heatsink across there, and probably could do us a bit of light. Let's go. And yeah, so we've got our, I don't know what order they're in. I think it's left channel, right channel, surround left, surround right, center, something like that. Anywho, these are our high power output resistors. I will show you them on the schematic shortly. But since the relays have not engaged, you know, we can't put a multimeter in here and check for bad you know, voltage coming out of there. So we have to check on the output resistors, and probing along, there was very little until I got down to the end, which had minus 50 volts. So we've got a plus and minus 50 volt rail to create our output from, and it was pulling hard to the negative rail. Now you might be thinking, oh, okay, output transistors probably shorted. Yeah, so I went and I checked those, as you do, and they were okay. And that's the two down this end. They were okay. The driver that drives them was also okay. Now we'll shoot to the schematic, and I'll show you how this is all connected. So we scroll along and find a schematic, and down here is our output stage, and along here, so down through the middle is our heat sunk output transistors, and the section that we need to look at is down the bottom here. So we'll enlarge that. It covers everything. Sorry. Not this row of transistors. It's the next row along. So we've got these red lines, which are our negative and positive 50 volt rail that go to our main output transistors. These are the this is the high high current, high power output resistors. So the transistor, the center of the resistor there, it's a twin resistor package, goes off to our output, and the two transistors are pulling rail each in turn to supply positive or negative to give us our nice, audio sinusoidal waveform. So what's happening is this transistor, the Q504, is turning on fully, passing negative rail through to here and to the output, so the protection circuit is detecting that and not allowing it to pass through to the speakers. So why is that? Well, our transistor is not shorted, and that can happen. It will just pass straight through then. We're getting a negative 50 volts here, so this is a PNP transistor, so it doesn't need negative on the base to turn it on, and we're getting negative 50 volts here. So what could cause that? Well, maybe this capacitor had gone short circuit. So I checked that, and that was okay, because if that did, that could pull full negative rail through to here and just force this to turn on. The other option is where the signal that would normally that would be the signal line is coming from. So we've got our minus V center and plus V center. So the positive swing goes through to, of course, this output transistor here, which is on our plus 50 volt rail. So we follow the minus V signal line, and that goes up to this IC package here, and it comes in pin 5. So I'm thinking, alright, maybe it's this package, but can we prove that? So I took some measurements along here. There's our input pin 1 and 2, and these readings, I believe, are turned on with no signal present. So we've got our positive rail in pin 9, we've got ground, and then our negative rail on 7, and then our outputs should be about a volt each. And yeah, so I've got my negative 50 coming out of pin 5 by the look of it. So I measure pin 1 and 2 for the inputs. Pin 1 seemed to have minus half a volt, which is a little bit higher than the 0.2. Pin 2 also had a odd voltage on there as well, and what I think was happening there, which I found out later on, pin 2, as you can see, comes down here through this resistor, down here, along here, and into our output, the center of the our double resistor package, a high current power capacity, high power resistor package. So that's directly on our output. So with negative 50 on there, what we have here is I think it ended up being about 2 volts or something. Like there's some kind of resistor divider action going on here. I don't know what internally in the chip could have been loading that pin as well. I'm not 100% sure, but that didn't seem right either. So yeah, it didn't really stack up. So I took this device out, and as soon as I did that, the fault went away, and the odd signals on these pins were gone. They were back to normal. So I decided, well, this IC must be faulty and giving us a false output, because it can't do its job, and thus turning on turning on our output transistor and full swing. So what does that look like? So that package lives down in here. where that row of holes is, that's where it attaches. And this is the package, an STR K840P. So I thought, what have I got to lose? And I gently removed the plastic cover. Let's go in for a closer look. And that's what we're looking at. Well, what we have here is, these are all transistors. It's basically what a transistor looks like on the inside. These are our output transistors, and we've got a bunch of resistors and some baby transistors through here. They're our input transistors, and that one there's a diode. Yeah, so I'll give you a closer look at those. So there's one of our input transistors. You've got your tiny wire legs, which are basically welded to the device, spot welded, and then I don't think they're soldered. They could be soldered to the trace actually. Yeah, so that's a little baby transistor. If we have a look over here, that is a so this is a diode package. Oop. Yeah, that's a diode package there. It's only got 2 wires going to it, and you can see with the transistors, like the one to the left of it, there's actually a trace going to the bottom of it, effectively, where it's bonded to the back plate. So that's 1, 2, 3 with the bond wires. This doesn't have that. It's just sitting on the plate with only 2 wires. So that is a diode, and if you measure across the 2 wires, you get your normal diode junction reading. So I grabbed my meter and I went around all of the transistors, probing on the pads, and being very careful not to touch the wires, little bond wires. I don't want to break them off. So I was just probing. There's a little gel coating on this board as well, so you got to break through that, but you can probe on the pads directly. You don't want to, like I said, don't try and avoid touching the bond wires if they break off. Well, you can probably resolder it, but you don't want it to break off the die of the diode or transistor itself. So probing each of them in turn, working out which one's base and collector or emitter, but you can basically check against that trace there, for example, is the bottom pad there to there and there. and you test them. And I went around all of them, and there's our output. Our 2 big output ones are a bit bigger. You can sort of see the pattern in the die. It's kind of neat how they create them. Can you get a bit more light on that perhaps? Yeah. So yeah, little pattern there. And I went around and I tested them, and like I said, this over here is a diode that had a normal 0.7 volt drop, and then I come over to this side and you can see I've already reworked it. This diode had a 1.2 volt drop across it. Now I removed this resistor up top here just to make sure that that was isolate the diode from circuit, so I wasn't measuring across anything, and checked it again, and sure enough it was only 1.2. That comes from the pin on the right here is our down the bottom right, that's our positive rail in, comes up and comes up the side, across, through our diode, and then into through this resistor. Better shot of that. Yeah, there we go. So our positive rail comes through the bottom right pin, comes up the side here, across through our diode, and then back out and up through the resistor at the top. So I figured if there was 1.2 drop across there, then our 50 volts coming out the other side is going to be a different value, and if that diode was breaking down, it may not pass much current, it may not do a lot of things it should. So I thought, well, why not bypass it? So I did. Here you can see I have extracted a random diode from a spare board because I don't know the spec of the diode, but it's only voltage, it's not signal or anything like that. That little diode there, and I attached one leg to here, which is coming up off that trace from the lower pin, and a jumper wire from the other side over to the resistor, which is where the output from this diode would have come from. And lo and behold, it's no longer in protection, and I no longer have a horrible output on the center channel driver. Now I have yet to test it with audio, but I'm pretty confident because it's sitting at a few millivolts, which is the same as all the other channels, and will be quite normal. So before I got too carried away, I just wanted to show you all that. I'm going to find a way to reattach the lid. It was glued all the way around the edge, so I just ran a spudger down the side and got in the side of it there, just a few mils in, because you see if I come in too far I would have come down and knocked everything off the board. So just on the very edge a little bit, and just hammered the end of it just to knock it down and break through the glue. You do you. If you want to have a go at something like that, just be very careful, because as you can see it's very fragile inside. Now I'm going to throw it all back together and we'll show you what's happening. Okay, here we go, turn it on with the module reinstalled, of course. Click, there it goes. I said click just as it clicked, but it's not saying protection anymore. So we need to get some speakers on this and test all the channels. Okay, so we have a just a left and right channel test. That was our left channel. Now right channel. Okay, now let's check the center channel. That was the one that had failed, and I have to choose, what do I have to choose in the menu to get that to work? Is it? Okay, so I had to put it on multi-channel in to enable just the inputs. I guess that goes directly through. I actually don't like the sound of that. I'm going to put the scope on that and see what that looks like, because that doesn't sound very good. Maybe something else going on there. Well, I wasn't happy with the sound coming out of the center channel, and I've been poking around with that little module, and I found out one of the little surface mount resistors there had broken loose. Just yeah. So soldered it on and everything's happy. Had a sine wave through it. It wasn't all distorted anymore. Now it's you know, here's some untuned radio. So yeah, just like a new one. Well, I hope that gives you another way of looking at things. Those modules aren't all magic inside. They have some basic parts, and maybe that'll help you with a similar problem. Thanks for watching.